is that this river of time can fork into two rivers. Or perhaps the river of time can have whirlpools and time can go in on itself. In that case, time travel is something you have to take very serious.
Time and space are like a fabric, like rubber, like a trampoline net. Turn this trampoline net into a pretzel and allow yourself to go backwards in time. Have you ever questioned what's truly out there in the cosmos? What mind-blowing mysteries the universe might be concealing from us? Well, you're in for a ride. We have a revelation so colossal, it's about to rewrite everything we thought we knew about the universe. Brace yourself as the renowned American physicist, Michio Kaku, unveils a discovery that's nothing short of revolutionary, brought to light by none other than the legendary James Webb Space Telescope, which may have proven that time does not exist. Ready to dive into a space-time riddle that's going to turn your world upside down? The James Webb Space Telescope is essentially the Hubble Space Telescope's bigger, cooler sibling. Launched on Christmas Day 2021, this telescope has taken up residence in space, illuminating secrets from the universe's darkest and most distant corners. It's like the ultimate time machine, equipped with super-powerful infrared instruments that make it perfect for peeping into the past. How, you ask? Well, its unprecedented resolution and sensitivity allow it to detect incredibly old and faint objects that even Hubble couldn't glimpse. We're talking about distant galaxies and celestial bodies from the early universe, those elusive entities that have been playing an epic cosmic hide-and-seek with us. In essence, James Webb is helping us piece together the universe's grand star-studded jigsaw puzzle, one infrared image at a time. Now imagine you're at an art gallery, strolling past grand pictures captured by the James Webb Space Telescope, also known as JWST. The imagery is breathtaking, with distant galaxies shimmering across the cosmic canvas. Yet among the astronomers and cosmologists, you see shock and disbelief. There's a sense of turmoil, almost as if they're staring at a Picasso in a room full of realists. The common phrase you hear is, "This is unexpected." So, what's the fuss all about? What's rattled the very foundation of their understanding of the cosmos? Although the official papers are tight-lipped about it, the real issue lies with a theory they hold dear: the Big Bang hypothesis. This is the idea that our universe kicked off in a massive explosion about 14 billion years ago, and has been expanding like a giant balloon ever since. This theory has been the cornerstone of cosmological understanding for years, and now the new images from the JWST seem to question its validity, sending shockwaves through the community. You can almost hear Alison Kirkpatrick, a seasoned astronomer from the University of Kansas, tossing and turning in her bed, questioning her life's work. Why is everyone so surprised? Well, the galaxies captured by the JWST aren't behaving as they should according to the Big Bang hypothesis. They're too small, too smooth, too old, and there are way too many of them. Let's try to simplify the too small conundrum. If you imagine the universe as an expanding balloon, galaxies shouldn't look smaller as they move away from us. After a certain point, they should start looking bigger because their light supposedly left them when they were closer. It's a weird but essential twist in the expanding universe concept. Yet the images from the JWST show galaxies that are about the same size as the ones near us. It's like you're expecting your distant friends to appear as tiny dots on the horizon. But instead, they're right next to you, just as large as life. Interestingly, they show galaxies appearing smaller than we'd expect. Even those that shine brighter and pack more mass than in our own Milky Way. These pictures show galaxies that seem to be 2 to 3 times smaller than the ones seen through the Hubble Space Telescope, also called HST, despite their greater luminosity and mass. Additionally, these galaxies also have significantly higher redshifts, which in layman's terms means they're supposedly moving away from us at faster speeds. You might think, well, that's odd, and you'd be right, especially if you're operating under the assumption that we live in an ever-expanding universe. A while back in 2014, some scientists had already pointed out this inconsistency. They analyzed HST images and found that galaxies with redshifts up to 5 seemed to match what you'd expect in a non-expanding typical space. It was anticipated that the JWST would continue this trend, and it has, even for galaxies with redshifts as high as 12. In simpler words, the JWST images show galaxies that appear the same size as those close to us, as if the universe isn't expanding, and redshift is merely a function of distance. But if we still cling to the Big Bang Theory and its expanding universe concept, we're left with a pretty perplexing conclusion. These distant galaxies must be unimaginably small to counterbalance the supposed optical illusion created by an expanding universe. It's a bit like imagining a grain of sand with the brightness of a spotlight. Take, for instance, a galaxy named GZ2 that the JWST spotted. It's far brighter than the Milky Way, but is calculated to be only 300 light-years in radius. Compare that to the Milky Way's 50,000 light-year radius. Its brightness per unit area would be 600 times that of the brightest galaxy in our local universe. Not just that, its density, and that of several other new galaxies, would be tens of thousands of times higher than the galaxies we see around us today. Now, when you consider these tiny and smooth galaxies, the notion of an expanding universe, and by extension the Big Bang Theory, starts to crumble. And that's why these findings are causing quite a stir among astronomers and cosmologists. Over the years, the Hubble Space Telescope images have given them a hard time. The pictures suggest the existence of many galaxies, dense and powerful, much like Mighty Mouse from old cartoons. These galaxies are a challenging puzzle for them, and with the new James Webb Space Telescope, things have only gotten trickier. To make sense of these peculiarly tiny galaxies, theorists have put forth an idea. It's as if you're playing with a tiny toy car, a magical one which, despite being only a centimeter long, weighs as much as an actual SUV. They suggest that these microgalaxies smash into each other over billions of years, merging together to form the full-sized galaxies we see today. It's like the toy cars colliding and growing up to be real SUVs. But here's the twist. The JWST has taken a close look at these galaxies and found no signs of such cosmic car crashes. You would expect these colliding galaxies to show some signs of damage, right? Maybe look a bit scrambled or mangled, like a car after a fender bender. But that's not what we see. Instead, the JWST reveals galaxies that are smooth, neat spirals, just like the ones we see nearby. There's an overwhelming lack of galactic fender dents. In fact, one study, aptly titled Panic, highlights that there are 10 times more of these pristine spiral galaxies than the theorists had predicted. This is akin to finding a busy highway with speeding cars but no accidents. It's a pretty significant blow to the collision theory. With no signs of galactic mergers, the idea that these tiny galaxies somehow expanded into their grander counterparts falls apart. If they didn't grow in size, it means they weren't small to begin with. Consequently, the optical illusion we'd expect from an expanding universe doesn't seem to be there without this illusion. The concept of expansion loses ground, hence the growing unease among Big Bang enthusiasts. The appearance of these small and smooth galaxies suggests that the universe may not be expanding. And if it isn't, the Big Bang Theory takes a major hit. There's another aspect to consider: the age of stars. The Big Bang Theory suggests that everything came into existence following the big explosion. However, if these galaxies existed before that, then it would mean the Big Bang didn't happen. This could be a game changer for our understanding of the universe's origins. Consider the James Webb Space Telescope as a time machine. In the words of Kaku, able to peer billions of years back into the cosmos, capturing images that shed light on the universe's origins. This incredible device isn't snapping photos in our familiar visual spectrum, though. Instead, it's focused on the infrared, revealing colors of galaxies so distant we could never observe them with our naked eye. Now here's the fascinating part. These colors aren't just beautiful. They're telling a story about the age of the stars in these galaxies.
Young fiery stars blaze a vivid blue, while their older cooler counterparts, similar to our sun, glow in hues of yellow and red. MIT physicist Max Tegmark explained this concept beautifully. He said, "We could view our reality as a three-dimensional place where stuff happens over time, or a four-dimensional place where nothing happens, everything just is. If it's the latter, then time is an illusion because nothing really changes. Everything, past, present, and future, is always there." It's certainly a lot to wrap your head around, but isn't it fascinating to ponder such questions? It shows just how frighteningly magical and mysterious our universe truly is. Then we have Julian Barber, a British physicist who has quite an intriguing perspective on time. In his view, our reality is a sequence of distinct now moments, like individual snapshots. Imagine flipping through a photo album where each picture is its own unique now. That's essentially how Barber views the universe. Barber argues that our perception of the past is simply a construct of our brain's memories. That is, we only feel like we have a past because we have memories of it. The actual concept of the past, according to Barber, might be an illusion. He further elaborates on this concept through his spatial theory. In this theory, each now moment exists in a place within a vast landscape, which he whimsically calls Plutonia. Every point in Plutonia represents a now, and this landscape itself follows perfect mathematical rules, making it timeless in nature. This perspective connects back to a much more familiar name, Albert Einstein. Einstein's theory of spacetime is central to our current understanding of the universe. However, its implications and our comprehension of it have sparked some critical questions. What if Einstein's spacetime concept was erroneous? Could discarding it entirely provide us with a clearer comprehension of the universe? The perpetual cycle. This idea may seem startling, but it's important to understand that the realm of science thrives on such revolutions. Theories are continually being challenged, refined, and sometimes entirely replaced. It's through this perpetual cycle of inquiry and discovery that science progresses. A look back into history would show us how this process has unfolded over time. The geocentric model, which posited Earth as the center of the solar system, was widely accepted for over 1,000 years. Then came Nicholas Cernus, who proposed a radical idea that Earth is just another planet orbiting the Sun, eventually replacing the geocentric model. After Cernus, Isaac Newton introduced a new understanding of gravity. He proposed that all objects with mass have a gravitational attraction towards each other. In this framework, the reason Earth orbits the Sun and the Moon orbits Earth is because of their mutual gravitational pull. Newton's gravitational theory held sway for around 3 centuries. Then, in 1915, Albert Einstein presented his general theory of relativity, which redefined our understanding of gravity and spacetime. Einstein suggested that massive objects like the Sun cause a curvature in the 4-dimensional fabric of spacetime. Earth orbits the Sun because it follows this curve, which we perceive as a gravitational pole. The transition from a geocentric model to Chernykh-heliocentric ISM, from Newtonian gravity to Einstein's general relativity, highlights the evolving nature of scientific understanding. Despite the solid foothold of Einstein's theories today, physicists continue to question, investigate, and push the boundaries of our understanding of time in the universe. Einstein's spacetime theory has held its own for over a century, fending off all challengers. A significant victory for it came in 2015 with the detection of gravitational waves. However, no theory is immune to challenges. One significant issue arises when Einstein's general relativity, which includes the concept of spacetime, comes face-to-face with quantum physics. The two seem to operate on entirely different rules, and this creates a bit of a problem.